I'm going to skip, not really skip, the statistical analysis. I would, rather than reviewing statistics, I'm going to jump into, before you get bored, the first well-known techniques of data mining today, so that you may not lose interest from this class. And statistics, instead I ask you to do basic, like mean, mode, median, on the first homework assignments, and I posted, and I gave you the reference for you to read web pages. Those are very, very simple. Those who wants to do Python, what I ask you to do, Python was required or optional?
No homework?
Yeah, homework.
Yeah.
Required. Yeah, there's very simple. So
Don't worry about it.
due is, I think, Sunday or Saturday, whatever. Yeah. So another homeworks will be distributed more often, because we do real algorithmic approaches and a little bit of hands-on. The program that we are using, a little bit of Python. Last year I spent more time on Python language for data mining, but this semester I'm going to use more on R script, because R has something already cooked, ready-made. And also many of you do not have yet Python skills. But R is something, is a language similar to Python, but not even like Python. Python is even simple language if you know Java or C. Python is a lot simpler than that. But R is even a lot simpler, which is kind of a tool. So if you know a little bit of the languages to get in R, then you can use it. But R has also very efficient and sophisticated the components available. If you want to do drawing, if you do that in Python, then it requires a lot of work. Even Python is simpler than C or Java for drawing. But if you use R, then all such things can be ignored, not really ignored. It can be taken care by R language itself. So you simply specify a little bit, then very fancy, sophisticated charts can be drawn. Okay, that I like the most when I use R. Let me give you a quick announcement. You probably know also. So the language one of the first technique of data mining is association rule mining. So I'm going to come back to this issue. Special announcement is I just arranged with the tech company, which is a tech system. That company came to our October cybersecurity event last year. This year, that company also come. That event is October 30th, which is a Monday. Okay, last Monday of next month, October. So I want all of you to join that event. The main speaker is from NSA. Speaker is not really a technical guy, but he's more, he's in charge of academia area. So, so that is the one thing that if you want to join NSA, you probably come and talk to that person. He has a strong connection, inside the connection. Inside the connection is very, very important. You know all, right? These days. Very hard to get in some entities if that one is really, really good, right? I mean, if you apply as a normal applicant. But if you know somebody inside, if that person introduces you to the right position, right department, right office, then highly likely to get in. So that is NSA positions or opportunities available. Jesse, you have a question?
What type of positions?
Huh?
What type of positions do they usually do?
They have all positions, all. Technical positions, non-technical positions. But the thing is this, if you know, if you demonstrate your techniques, skills, then a lot easier to get in. Okay? But for others, non-technical positions, still possible, but very hard to be evaluated if you bring that to that person, right? How can you demonstrate that you have some humanitarian capabilities which is related to NSA mission? But techniques, we all know that, right? Which techniques they are looking for. One of the hottest techniques they are looking for these days is wireless communication. It is booming. There are not much yet solid solutions. There are not much attack yet, but highly likely possible in the future. So they need to prepare. Another opportunity, if you want to, if you are interested in positions, civilian positions, some industries, job, like a headhunter company will come. They hire a lot of Mercy graduates. Not for them, for their companies. Their companies is a recruiter, right? Headhunter. They relay application to possible companies, right?
Robert Half, right?
Huh?
Robert Half, don't they like?
Theirs is their company name is called the Tech System. That company, the lady and the team coming into our event covering Westchester and Connecticut. But they have also their companies in the city. If you want to work for example, Wall Street and some big Fortune 500 media companies like Fox News, NBC, CNN, then they also have. So bring your resume. I want you to prepare your resume. You have about a month, right? So write a very fancy and solid resume. If you have skill sets to demonstrate. There are a lot of tips. I think you already know. how to write your resume, do not make your resume like a department store. What is department store? They display everything, and when customer comes and find out what you want. That is not a good approach when you write a resume. You display everything that you have, you know, and then you can ask the job recruiter, if you're interested in, find out. Is there anything that you are interested in from me? No, they are not interested in, right? So you have to describe as minimum as possible, which means you have to make a multiple different version of resumes, so that, hey, I want to interested in the position in network, a specific, for example, software-defined network. Then put something about software-defined network, or some wireless communication. Then you describe something solely on wireless communication. Some development positions, then describe all the host language, basic languages like C, Java, or Python. Okay, and a lot of portfolios, if you have, described there in detail. One page is usually good, but 2 pages long, then if you are really good, then you may probably write a 2-page long resume. But 1 page is usually good, right? Don't write too much, but you have to focus something that you want to demonstrate, and something that skills or any items that you include should be related to the positions that you are looking for. Okay? So do not describe everything that you have. Very funny thing is, I was working for cashiers some places. Don't write such things, okay? That doesn't help at all. Somebody also, I know Office, Microsoft Office, Excel, all those things. If you write that things, then the recruiter or interviewer think, this guy does not know. Okay, next. They can flip around, right? So you have to, if that is the technique that you know only, then you should write it, and you have to look for such positions. But if you want to look for little sophisticated positions, then skill sets that you know should be matched with that positions. Okay? Don't try to do, for example, Microsoft Word, Windows 7, Windows 10, remove all. Everything about Windows is removed. Okay? So Linux, something about Linux. Then you can find the distant positions. It doesn't mean that you cannot find Windows positions. Then you need to apply for that level. Okay? Or everything about Microsoft and Windows, Microsoft Offices, and everything about .NET, or everything about Windows, Microsoft products. That is fine, right? Some small companies, they know they are looking for such. All right, so that is October 30th, Monday evening. I think starting from 5 to 8 for 3 hours. If you come early, then you can talk to the recruiter. Recruiter will come around 4:30, so that you have more time to talk with that person. A lot of our graduates got a positions through that company. James, you have a question?
It was like 5:30. Starts at
4:30. That recruiter will come by 4:30, but whole program event will start at 5. Okay. Question?
After work. They're saying, can you send an email though, so we know? But it's fine. It's going to be on Blackboard or something, so within a day. What day did you say it was? 30? Alright.
Oh, I'm going. Oh, yeah. I'm going to put that on
Alright.
scicure.org.
Yeah.
Okay. Chapter 5 of the reference, one of the major reference. Techniques that we are covering today in part from the textbook. So, but I think a slide itself enough. We're going to spend a couple of weeks on this subject, but today we're going to discuss about the algorithms only. This association rule mining was proposed by what is his name? Yeah, Agarwal, Rakesh Agarwal, early 1990s, right? 1993, yeah, 93. Agarwal. When he was in IBM Almaden Research Center, which is the West Coast. So we are going to use the examples that he wrote up on his first research paper. Okay. What that research paper described was frequent patterns. Pattern is like some predicates. Predicate that we discussed 2 weeks ago in logic. For example, variable and value pair. If you look at grocery basket, somebody's grocery basket, then you can count. Hey, this guy has 1 pack of beer. Then beer and number of pack, beer equals 1, means 1 pack of beer, for example. Okay, depending upon that may vary depending upon your representation. Pattern, that is one single pattern. But we can make a little longer pattern. Not only the beer, but also beer and what else? What are the groceries? Chips. Beer and chips goes together very well, right? Beers and chips. Chips also 1 pack or 2 packs. Altogether, beer and chip data can be a pattern. You may think of a longer and longer and longer pattern. So the idea behind this association rule is to find longer patterns, but it should occur frequently. Okay? So frequency needs to be measured. How frequently some grocery items are picked up. The more often the picked up items are the pattern that we are interested in. How can we find out? So this guy is, described that in algorithmic approach. So as shown in this slide, in that motivation to answer to the questions, some sample questions there, this frequent pattern analysis becomes so popular. For example, what are the subsequent purchases after buying a PC? Right? If you go to Amazon.com and if you choose to purchase one item, they never forget to suggest you some other additional items by saying that those who purchased the item that you just purchased also purchase the following items. If you see that suggestion, then you may feel that, oh, that is a very good idea, right? You choose one item, then the other items highly related. For example, if you want to buy electric drill, then they never forget to suggest you to buy drill bits, right? And other options. That comes from that this idea. Okay, more frequently, drill and drill bits together, joined together, we call that association. So association of drill and drill bit occurs more frequently. Okay. But if you find some rule, for example, there is a incident and consequent. Okay, there is a conditions and conclusion, conditions and result, or incident and consequences. If there is some cause and effect relations or correlations are described, then that is another things that we want to find. That kind of rules is much more valuable than just raw data of a million records. For example, I can give to you, oh, here's the result, and then I give you a spreadsheet, Excel files, which has a million rows and 20 columns. If you are CEO, or if you are a potential buyer, but if I said, oh, this is good products, and look at these guys, they are also looking up the item that you are interested in. If you say that by providing raw data, which is not more effective or as effective as the patterns that you first processed, saying that, oh, those who purchased X also purchased Y. How many percent of customers? Oh, 75% of customers. How accurate it is? Oh, we have X amount of confidence. So all such measurement also provided. So a lot of applications available. Basket data analysis, cross-marketing, catalog design, sale campaign analysis, web log analysis, like a click stream. Somebody clicks address A, then highly likely subsequently click address B and address C and D. Some sequence of or click streams may be able to be known or forecast. DNA sequence analysis. A certain sequence of DNA may cause, for example, some type of cancer in next 5 years, for example. Okay. There may be a lot of hidden patterns in almost all various different applications. But only problem is that we do not know. We don't find all, right? Why frequent pattern mining important? Frequent pattern is an intrinsic and important property of data sets. Data sets is nothing but a set of data, raw data. But from there, you may be able to find out some frequent pattern. And so patterns can be, those frequent patterns can be formed by association or by knowing correlation or causality analysis. Sequential structural patterns are also kind of frequent or our interest, patterns of our interest. Some patterns may be described in spatial temporal. So a lot of researches have been published because it started in early 1990. So in 1990 and 2000, 2010, longer than about 25 years old techniques, right? So a lot of algorithms developed. The patterns that I described, for example, Rakesh Agarwal's the example, grocery examples. Those who buy beers also buy diapers. Okay. But if we describe that in spatial temporal as follows: those who buy beers in rural area during summer season also buy diaper. Temporal aspect may not be really critical, but special aspects like rural area, that is highly likely very, very important in that pattern description, right? Those who purchase beers in rural area also buy diapers. So once they get home in rural countryside, rural side, then they don't want to come back to the city areas. So during weekends, spatial temporal, to make that pattern more sense, is that those who purchase beer in rural area on Friday afternoon also buy diapers. How often? I think 90%. Confidence, maybe 99% confidence. by attaching spatial temporal patterns, the pattern that we just described gain a lot of strength, right? Multimedia, time series. Time series also very, very important in data mining. Patterns can be described in over the course of time. Some pattern at time t1 and another pattern at time t2, then at time t3, highly likely the pattern 3 occurs. That type of patterns are also very meaningful, right? And many others. So techniques that we are learning today is association, rule mining. Basically, in this semester, we will look at 3 major techniques of data mining: association, rule mining, and classification and clustering. Classification and clustering. Okay, each such techniques will look at the concepts, algorithms. There may be multiple algorithms developed, so we'll pick one or more algorithms, and also hands-on labs. Try to use tools rather than programming, coding. Although I like coding, I know some of you like coding, but not all of you. And I know all of you still wants to use some tools. Okay, some tools are really, really good. So knowing the tools more fluently, you can also get a good position easily. For example, R. Okay, so R has full spectrum of tools. Okay, so here's an example. So basket, transaction ID, TID, or you can say basket. So when you go to grocery stores, you pick up baskets or cart. Into it, you pick up items, right? So somebody looked at the baskets and find out some frequent patterns. So if you look at transaction ID 10, then that basket contains beer, nuts, diaper. Another basket contains beer, coffee, diaper. And basket 30 contains beer, diaper, eggs. So among items, there is no order, right? It's like a set. There's no order. It is not a sequence, but it is a set. So we can think of a multiple. So basic idea here is that you need to think of support. So how frequent that occur? That means the support. So support, the maximum value of support is 1, minimum 0. Or if you want to describe it in percentage, then maybe 0% to 100%, right? So support may be in two kinds: absolute support or relative supports. Okay. So relative is based upon some condition, right? On item set X is frequent if X support is no less than a minimum support threshold. So when you do mining, we can give minimum support threshold, which means I'm not interested in some pattern that may occur once in a century. Why? May not be none of my business, right? So I'm not going to live 100 years in good condition, right? No one live 100 years in good intellectual conditions. I think at longest maybe 50 years, or 50, or I think more than 50, right? Let's say 10 years old, then let's assume we have some intelligence. So from 10 years to 80 years, over 80 years, then brain is not fully functioning, right? I mean, 80% of the 80 years old people not really actively using their brain, I guess, right? I may be wrong. But anyway, there is a certain time period, not definitely 100 years. So if somebody says, oh, this occurred, this is very, very, very important. Once this occurs, then the consequence is so significant. So you have to take care of this. How often does it occur? It occurs once every 100. Or once every 200 years. Then that is not my interest, right? So what I mean by that is here is a minimum support. Okay, I want to some patterns. It occurs if entire set is my database, then from my database it should occur 20% of my database. Then you can apply that 20% in all. If you apply that time span 20%, then like a year, 20% my calendar years it occurs, which occurs so often, right? At least 20%, for example, or at least 10%, or at least 1%. Okay. At least 1% of money transfer transactions, there is some error. What happens? Bank systems, between banks, there are a lot of money transfer transactions. 1%, that is too big, right? Frequent. So once we have a frequent pattern, then we can from pattern we can make a rule. Rule is we have antecedent and consequent. Okay, if then type of rule. For example, if beers, then diaper. If diaper, then beers. This kind of rules are what we are interested in. When you describe a rule, then we have to think of two basic measurement. These two basic measurement were proposed when first time this association rule mining was published. Okay, after this, after, I mean, since 1993, last 25 years, there are a lot of different measurement proposed. When I saw this, at first, I proposed around this time one measurement, which is called the interestedness, right? Interest. By using some negative examples. Okay. The idea is this. If you look at database course class enrollment database. Think about that. Course class enrollment database. Then database contains all the students' names who are enrolled in the class fall 2017. Right? That's a database. So there's a lot of interesting and frequent patterns can be mined. But one thing really interesting to me is that some patterns, if some patterns describes saying that this kind of students are not enrolled in fall 2017, not enrolled in, some negation, negated fact is not available in my database, right? My database contains all positive values. If that is an enrollment table, then this students enrolled in this class, another students enrolled in another class, right? Student name and class number and so on and so forth. But we know, if we have a database, then we know that entire student body, right? And also we know students who are currently enrolled in. If we subtract them, then we know those students who are not enrolled in fall 2017. And then there is some pattern saying that, those who having some problems, financial issues, or whatever reason, then they don't come back to school. That type of negative factor may be more interesting, right? So that is another factor. But let's stick to this. So, as I said here, support is a probability that a transaction contains X and Y together. Confidence, once X occurs, then how many percent Y also occur? Because this rule says if X, then Y, then the entire data set is X. So something over X, that is a confidence. But if we consider supportness, then support should consider entire database. This is the entire database. Entire. This is only based on the fact the if part is satisfied. The if part of the rule is satisfied. So something over X, something over everything. Okay? For example, support is this. If somebody said, if raining, then this is an error, right, in this case. If raining, then the other one is better, right? If shining. Last. If sun shining, then picnic. Okay, sun shining, then picnic. How often this occurs? Then look at the database, look at sunshine and picnic, and count how many records has the sunshine and record together, sunshine and picnic together from database. Let's say my database, whole database, there are 100 records, but out of 100, 25 of records saying that shining and picnic together, right? Then this is a support. This is support. Soup. So that rule has 25% support from my database. That's what it is. On the other hand, the confidence, how accurate it is, how confident that rule is. So when you look at the record, first to look at the record which has shining. So count all of them. Oh, there are about 45 shining days. 45 shining days. How many of them that guy go picnic? Or 25. Okay. Support maybe 25%. Confidence maybe over 50%. In this case, maybe 53%. I'm not sure how much it is, but support 25%. Right? That's what this means. So, you can simply say here, if beer, then diaper. What is the support? Then you have to count, right? How many databases? We have 5 databases, 5 records, right? 5 records. How many of 5 records? This is the entire database. Entire database is 5. Size of the entire database. 5. How many records have both beer and diaper? So record 10 and record 20 and record 30. Record 40 has nothing. Record 50 has a diaper but no beer. So 3. So 3 over 5, which means 6%, right? What about confidence? Confidence is you have to first look at the record which has a diaper. So which one has, beer? Which record has beer? Beer. This record has beer. This record has beer. This record has beer. The other 2 does not have a beer. So something over 3, right? So number of records having beer is 3. So how many of them also diaper? So this one has diaper. This one also has diaper. That one also has diaper. How many? 3. Now out of this, 3. How many? This 3, right? 3, which is 100%. confidence, you have to think here, entire, it doesn't not compute based upon entire table, but those table, those records that's satisfied by if conditions, right? That's what I wrote here. Based on the fact the if part is satisfied, which means 100. Question?
The diapers happen 4 times.
Which one? But this one has typo, but it does not have a beer. Remember that this one, based upon the fact such that the if part is satisfied. So you first count the records that satisfies if part, which means there should be beer. The other does not have beer. So something out of 3. This is a 3. So among these records, how many of them are also taking diaper? That's what we count. What about the other way? Diaper, if diaper, then beer. This is the same as that, but let's consider this. If diaper, let me choose another pen. Okay, here. So which one has okay. So here, denominator, I need to find out diaper, okay? The number of records that have diapers. So I have here diaper, 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 and here diaper, right? How many? So 4. Okay. How many has a beer among them? So I have beer, beer, and beer. That's it, right? So 3 out of 4. Confidence. Understand? So idea, that's very, very basic idea, right? So can we, the thing is this, right now, this is a rule, right? But very simple rule. Left hand side, the if part, we have one pattern. Then part, we have only one pattern. Is there any possible that, for example, pattern 1 and the pattern 2 and the pattern 3, then pattern 4? Let's compare this. This is only pattern 1, then pattern 4. Which one is more significant in description? For example, engineer major can get can earn 6 figures, for example. Okay, engineer major. Somebody says engineer major has 6 figures. Let's say this is a rule. Another rule says engineer major and graduate in city area, and age is about 30, and what else? And having beers. And 6 figures. Compare those two patterns. Which one is more applicable? This is the whole thing, right? This is more specific. If we apply this and find out, am I graduated college in city area, or what is this? Yeah. Am I 30 years old? Do I have some years and things like that, right? So idea here is that rather than having this small piece of description, multiple small description, if we have this kind of longer pattern, then longer pattern but having also same support or higher support or confidence, then this kind of a rule is more significant and also useful. So then which one that we want to find? A long pattern contains a combinatorial number of sub-patterns. Let's say if we have 100 attributes, then how many sub-patterns in theory are possible? One pattern describes over only one attribute. So out of 100 attributes, only one. That is the case that we looked at here, right? Only based on one attribute, like this. Plus, so all kinds of such available. So combinatorics of 1 over 1 from 100, the combinatorics of 2, 100, the combinatorics of 3, 100, and all the way to combinatorics of 100 and 100. So how many sub-patterns theoretically possible? 1 times 10 to the 30, power 30, sub-patterns available. Reason that we want to do data mining is that if rather than having a very long list of data sets, if there is some summaries, if there is some rules that covering most of the databases, then that is more valuable, right? That's meaningful. That is the knowledge that we want to achieve. Therefore, we need to do data mining. But if we receive these many rules, there is another big data, right? I want to have rules that can cover my big data. Is there any simple or short number of rules so that I can understand billions of data sets that I have? This 10 to the power 30 is a lot bigger than billions, right? 10 to the power 30, what is it? Anybody knows that? Anybody counts up to that number? No, almost not, right? trillion is 10 to the power 9, right? No, billion 9? Yeah, billion is 9. Trillion 10 to the power 12. 10 to the power 15, maybe zillion or whatever. Can you count up to 10 to the power 21? What is the name of that? We don't know, right? There's no name. That many patterns. Somebody said, oh, I found my powerful data mining packages finally found out. Here is it. 10 to the power 30 patterns. So basic idea, what is our goal? We should do maximum pattern, maximum number of patterns. And it should be closed. If Y covers there is no bigger ones, okay? That's what we want to find. The algorithm is this a priori algorithm. We need to describe two things, two sets of data, two item sets, candidate item set and frequent item sets. The first phase is that let's create a candidates. From the candidates, we need to find a frequent item set. Candidate item set, there we want to generate frequent item set. Finally, we return frequent item sets only. Okay? Those who understand the pseudo algorithm, pseudo code, I want you to find it, read it. It's not really hard to understand. But if I describe in this example, then you know what it is, right? Let's say this is a database, entire database. Okay? There are some of the items in that databases. First thing that we need to find is candidate item set. The first candidate item set, this is a bottom-up approach. Our goal is to find the patterns that is described over maximum number of sub-patterns. Maximum sub-pattern, max sub-pattern means there is no super patterns that have the same support and same confidence which contains me. Then I am the max pattern by the definition. Okay? So bottom-up approach, which means we have multiple different items here. Let's say start from one single item first, and then we can join, which means 2 items, and then 3 items, and then 4 items to achieve maximum patterns. Okay? How many items that we have here? A, B, C, D, E, 5 items, right? So let's consider, let's take single item at a time. So B, C, A, B, C, D, E. And then we need to count, okay? Frequency needs to be counted. How many A appears in this database? 2 times. 2 A's. How many B's? B, B, B. 3 B's. How many C's? C, C, C. 3 C's. How many D? Only 1 D. This is 1 D, right? How many E? 3 E's. Let's say my minimum support threshold is 2. This is a condition, okay? 2 out of 5 means 40%. This guy says, I am interested in the patterns if pattern has at least 40% of support. 40% or higher. Which means I do not want to any pattern that occurs less frequent. I want to pattern that occur more frequently. So let's reject this according to that threshold. Then, see here, this is a candidate item set. From there, we remove some items which do not have enough support. This is a threshold. The threshold is 2. So what's left is my frequent item sets. Frequent. Those are frequent. But I do not stop here. Why? I do not know yet if there is a bigger, maximum frequent, more frequent can be associated. My goal is to have longer description rather than each single atomic description. Okay? Make sense? So we have this. So next step is very, very important. Next step is that we need to join pairwise. That is called association. So we have A, B, C, E. So all possible combination. A, B, A, C, A, E, B, C, B, E, and C, E. Order is not important in this a priori algorithm. But another version of data mining, order is also important. AB is not the same as BA. Right? Some applications, order is important. Grocery stores, order is not important. But where? Restaurant. If you go to a restaurant, the order is very, very important, right? Do you order dessert before you take appetizer? Or appetizer first? Order is important, right? Sometimes we eat appetizer only. Right? Usually appetizer is delicious. But anyway, appetizer comes first. Is there anybody go to a restaurant and give tips first before you eat? Oh, you do? You'll be my customer. Come to my restaurant and give me tip and say bye-bye. So, some data mining, some association rule mining, some different version of association rule mining takes the order into consideration. Another version, time. Time is associated. Another version, space is associated. Another version, time and space together. So spatial temporal aspects also considered. There are many different versions. Some other versions, in this case, the grocery store examples, they didn't consider the amount, the volume. Some other version of data mining also consider the volume. Those who buy beer also buy diaper. Not just that. Those who buy 2 packs of beer buys 3 packs of diapers or something like that, right? Different number, maybe associated. So all different versions of association rule mining or a priori algorithms developed. But the algorithm that we are considering, once you know this basic algorithm, then you can understand the others very easily. And also you can apply. If you apply this to, for example, cyber security. What would be a good example in cyber security? For example, network attack. Let's say some attacks from country A and similar attack from country B, then real attack from country C. Something like that, right? Some sequence. Somebody really attack our server, then they do not attack from, not directly from the host that attacker is using, right? That attacker is hopping from one host to another host and another host, and a real malicious attack occurs. That attack comes from some countries that we cannot investigate, like a country C, okay? Then we cannot, they don't cooperate. But anyway, in this basic algorithm, we do not care the order, but if you need to care, then you have to the candidate item sets will be much bigger than this, right? Because order should be included. A, B is not the same as B, A, so you might have another. But anyway, if you have this candidate item sets, then you have to count. Okay, you need to get the frequency. You need to get support by as we counted here. How many records has A and B together? A and B together. Only transaction ID 30. So number 1 here, right? And how many have A and C? So TID 10, TID 30. So there's 2 occurrences. Frequency is 2. How many records has both A and E? A and E together, that is transaction 30. Only 1 records. How many records have? How many records having the item sets B and C? B and C. Transaction ID 20, transaction ID 30. So 2 of those. How many for B and E together? So transaction ID 20, B and E, transaction ID 30, transaction ID 40, so 30. I mean 3. So we have this many. So we drop item sets which do not satisfy the minimum support threshold. Minimum support threshold is 2, right? So that this needs to be out. So next one is, from there we need to have the higher layered the frequent item sets. Frequent item sets are extracted from the candidate item sets if item sets have more than the minimum support threshold. So that we have a BC, AC, BC, BE, and CE, right? We keep doing this. From here to there, from one atomic item to a pair of items. That is simple, right? We simply associate. From here there, association is not really simple. So there are many different approaches, techniques developed. One of naive approaches is that all possible combinations can be described here. AC, no, it's not all possible. Still, that is among, based upon the item sets, previous item sets. Naive approach is that comes from here, A, B, C, D, E, and make all three combinations. So A, B, C, A, B, E, A, B, D, A, B, E, and things like that. That is all possible, right? But we don't consider from here, but based upon this. So look at this, AC, and can you find out something? Then we can see A, B, C, right? So we have A, B, C. A, B, C, right? And then also ACE, because we have AC and CE, so we have ACE. And we have a BC, and we have a B here, so BCE. And here, what else? There's no further, right? Based upon this, so we have this candidates item sets, and then we need to count how many of them having this. We can count here like others. So support. How many have A, B, C? How many records have A, B, and C? A, B, C, A, B, C. Only one record. Item transaction ID 30. So only one, right? ACE. How many has ACE? AC here. Only one here. BCE. Transaction ID 20 and transaction ID 30. So two of them here. So these two will be out, right? Out and out. Therefore only one. Okay? This is the maximum. Why this is the maximum? There is no other superset that contains this and also meet the support threshold, the minimum support threshold. Right? So this is. So that is the algorithm. Question so far. Since the algorithm is very, very straightforward, you can implement it with no problem. Okay. So this is another implementation. Example for that is there are this is a very old data mining or machine learning archives, which was saved at University of California, Irvine, in the Department of Information and Computer Science. So if you go to archive.ics.uci.edu/ML, ML stands for machine learning and data sets, here, then you can see sample data. Okay, so let's go there and take a look at together. Okay, the address is that uci.edu/ml/datasets.html. It's a lot of repositories, right? So you can see the characteristics of the data. Data type, multivariate. Default task classification. A lot of data sets used for classification. And very few, I think so far I can see only one, clustering. Almost all are for classification. If there is nothing, then you can apply association also. Second clustering data sets, and some regression, which is a statistical approach. The one they described here for the type is this is a data sets about 20 years ago or 10 years ago. Some other researchers tried to demonstrate some superiority of their work. Then they used the same data sets because other publications also used the same data sets, and they have some evaluation data. So some other guys, if they want to beat the previous publication, then they use the same data sets and then approve, for example, their performance better than the others. That type of things. So this is a benchmark. The repository that they may be able to use. Okay. Number of records, size of records there. So for your project, for example, for your group project, if you want to look at some of the data, then you may download the data sets from here. Collected, this is number of the years, 1995. Data about 1995 or 1994, the very old data sets. Okay, very, very old. So default task classification 289, regression 74, clustering 69, attribute types, categorical attribute type, numerical attribute type, and mixed. Numerical, you know that by number, right? Categorical, if it is not a number but text, more precisely some value, not numeric but alphabetical values. Somebody say height, then value is tall, very tall, average, or short, very short, that type of things, right? They are categorical. Or, the other way. Yeah, categorical more precisely in this way. There's different height. Therefore, let's say if we describe that in centimeter, 170 centimeter, 170.5, 171, 172, 173, something like that. They are all the numbers very adjacent. They are very close to each other. There is no way that we can cut the values. Then we can define, hey, this is a minimum average height. Average height, by the definition, can be 165 to 175. We categorize the numbers and then make the values simpler. Same thing for your grading. Okay, so for this course, for example, I collect all the data that you achieve from your homework assignments, your projects, and your exam, one-time exam. I collect all the numbers. Then your numbers dispersed all around, from 100 to down to maybe 65. There are all kinds of numbers. If we have 100 students, then maybe 66, 66.3, 66.7, and something like that. When I describe patterns with that number, then I have the problem that, remember that the pattern should be simpler, but max patterns, which covers more supports. But if I describe student, let's say, if student grade is 83.5 and student age is something, let's say, if I describe that pattern, then how many supports that such a pattern can achieve? It could be very low, right? Because not many students has that exact same grade, 83.5. Not many students have also exact age 23, which is no good because the values dispersed all around that boundaries, right? So we categorize the values, not just saying a specific number scale. We better say letter scale. Okay? So grade is B grade or B plus. Then there are many B plus, right? That is a categorical data sets. Numerical or categorical, and so on and so forth. So that is the data sets. And another one, I want you to apply our original okay. Let's say transaction 1 has beer, nuts, diaper. Transaction 2 has a beer, coffee, diaper, beer, diaper, eggs, nuts, eggs, milk, not meals, and so on and so forth, right? So I want you to apply. Remember that earlier slides, the first example? I want you to apply the algorithm, a priori algorithm, right now. Remember that candidate data sets from their frequent data sets, and make another candidate data sets by associating, by including one more attributes. What I mean by that is I want you to apply this. Okay. Right now, manually. Meanwhile, in R, no, not this. What it is? What is it? Type of data. Okay, this is the data. I'm going to change this to milk. Okay, so I have milk, eggs. So this is a spreadsheet, right? So I'm going to save this. And I'm going to use the tool, so R. I'm going to show it to you, so you will know this next week. But today, you first understand the concept by manually. And I'm going to, if you do this manually, then you might have this. C minus so I'll script if I run this, there's all. This is the rule that we find here, left hand side and right hand side. For example, if beer, then diaper. How many support? 60% support. Confidence, 100 confidence. The other way, if we diaper, then beer, 60% support. Remember that is the same, 60%. But the confidence is 75%. Right? We had that. It is not. This, right? Some pictures. This cancel. Okay, here. If beer diaper 6% and 100%. Beer and diaper 6% and 100%. Diaper, if diaper then beer. Diaper then beer, 60 and 75%, right? There's this. And more than that. And there is a maximum pattern. Milk and nuts. If somebody purchases milk and nuts, then buy eggs. 40%. But I'm sure 40% of them definitely buy, if they buy milk and nuts. We didn't know this, right? From this. Let's say milk and nuts. If those who buy milk and nuts together, milk and nuts here, and milk and nuts here, right? If they buy milk and nuts, they definitely buy eggs. See, there's the eggs, right? 100% confidence. If somebody buy egg and milks, then buy nuts. So apply, this is this, exact same one. So I typed that in spreadsheets and changed that to CVS, comma values, comma separate, CSV, commas separated value. And that all script, read that and generate this kind of a word. Okay? So do it now. And those who need to break, freely take a break, and I want you to do this. So I'll give you about 10 minutes to do this, and then what we will do for the rest of today, maybe another 20 minutes, so all, we need to download all and a little bit of, oh, by the way, I need to guide you to download. If you, where can you download? You need to download it from from here. That is already posted. You see that, right?
Yeah.
So you can download it from crn.berkeley.edu or www.rproject.org. There's R Studio, R Script, also CRN. If you download one, then you can have both a Studio and Script, two different versions. Okay, Studio. So I'm going to show to you how can you use a Studio, how can you use the Script. The one that I gave you the demo there, this, that ran the script, right? See here? This is a command. All script followed by the file name. All right?
you have that? You might have some antivirus program that works very strictly. So it's one now.
Move away, let's see your antivirus. Oh yeah.
I mean, the first one works, so I mean, I figure this one should too. It's probably just showing that it's happening. This one actually, it's my program license is showing.
When you apply a priori algorithm to this example, the first thing that you need to identify is a number of items here. So beer, nuts, diaper, coffee, eggs, milk, right? About 5 items. And then you have to count how many times each occurs. And then you need to set the minimum support. I would say minimum support threshold, which is 2, as we looked at the previous slides, and apply that. So I want you to do that. Therefore, the next homework assignment is that I'm going to give to you. Similar example. I'm going to add a little bit more here so that those who practice this can do their homework assignments very, very easily, right? Let's say I can put here, what else? Coffee, wine, cheese, what else? Eggs, and another wine, cheese, nuts, maybe somewhere here wine, and cheese, wine, and diaper. Okay. Let's see what happens, right? Do you want to format and then also associations, current folder, and diaper, save, yes, no, cancel. Okay, if I run that, okay, confidence support's reduced, right? Beer diaper 37%, diaper beer 37%, cheese wine, oh, that looks fine, right? If cheese, then wine, wine, if wine, then cheese, milk and nuts, so that type of things. Okay, so that'll be your next homework assignments. Oops, I'm going to don't save it and download. So if you go to that website, https://www.allproject.org. Download R and CRM mirror, that is fine. So probably the one that I downloaded, usually here CRM Berkeley or somewhere. Okay, so from Berkeley there's a Windows version, Linux version, Mac OS 10. So once you download it, properly, then it can be downloaded. So where is it downloaded? Yeah, it's in program files and all. The version that I have, that you might have also, 3.4.1. And if you click binary bin under all-3.4.1 bin directory, then you have R and R script, and coming back here, and also icon automatically, I guess, on your desktop. So this one is all 386. Similarly, two versions, right? The icon as a shortcut on your desktop, if you click, for example, all 64, then Studio will come up. This is the Studio. Okay, this is the Studio. I'm going to bring this back here. And then if you holding down Windows button and all, then that is command. For Mac users, it will be much simpler. This terminal is nothing but the terminal there. If you holding down command button and spacebar, Then there is like a search engine, search box, text box. You can type there terminal. Then you will have a terminal like this. But that is a Linux terminal. In Linux terminal, you can type R or R script. This is R. So I want you to read R version 3.4.1 released this year. It's a free software, comes with absolutely no warranty. You are welcome to redistribute it under certain conditions. Type license to for the details. Natural language support, but running on English locale, so we are okay. R is a collaborative project with many contributors. So you can see the contributors. For example, like Python language, this all is also based on function. So if you type contributors for more information, contributors. So I don't see any. License we do have, right? But not contributors. So you can see some of those. Okay. If we want to so this is R script, and this is R Studio. Okay, in R Studio you can do more user interactive. You can practice something here. Okay, that is available on here tutorial. Something, as I said here, you can start R Studio or R script. This is R Studio. Okay, so if you want to see the packages already installed, then type installed packages, then it lists all the packages already installed. Okay, some of the packages that we are going to use. But R itself does not have the association rule mining. But it has classification and clustering. One of the techniques used for classification is some distance function generations. So some nearest neighbor functions can be found here. A rules is one of the association rule mining, so we are going to use that also. In R Studio, we can practice some of this, right? So 3 plus 5 plus 3, then it returns the result of that. So it can be evaluated quickly. Log 8 base to 2 is 3, right? You can calculate that. Or log simply 8, then there's a much smaller, because without number 2, then there is a 10 base. Absolute values can be also find. For example, -3, absolute value -3 is 3. Absolute value 3 also 3. And square root 9, that is also 3. Square root 10, little bit over 3. Square root 8, so smaller than 3, right? If we type ls, ijk my file and xy, we'll find out, right? So some of this will be practiced next week. So basically there are two ways that you can use. If you want to use R script, then you need to create a file of R script. For example, the one that I ran a minute ago. Oh, here, this is the contributors, right? All contributors here. Here, I use the all from all A rules. A stands for associate. So I use the associate rule. Simply, I read the file data.csv, and then make a item set. Here, rules. Item set is support point to 20% and confidence over 50%. And then I describe that in certain order. I made the order, right? Order by support. So highest support comes top. That's what I did here. So this is from there. If you want to quit, then Q workspace save. No, I don't save it. But if you run simply the script file, then you need to do R script followed by the file name. Okay, that's what I made. I ran this and it shows. All right, any question? So next week I want you to bring all R Studio and R script. Then we'll practice. I'm going to teach you basic of R command all the way up to a specific packages about association rule mining, which is called A rule. Okay, so that's what we are going to do next week. And then maybe tomorrow or this weekend, I'm going to give you one simple next homework assignments, as I explained a minute ago. All right, I'll see you next week.